Look at the law of cosines. Now, in any triangle, the sum of the lengths of any two sides must be greater than the length of the remaining. So let's look at ABC. And this is an oblique triangle located on the coordinate system like we have. Now, the coordinates of A are x, y. For B, I know sine of B is y over c, so y is c sine B, and cosine of B is x over c, so x is c cosine B. So the coordinates of A become c cosine B, c sine B. Now the coordinates of the point C are A0, and the length of AC is B. Use the distance formula. We have the length of B is c cosine B squared, B minus A squared, plus c times sine of B minus 0 squared. We're just doing the distance between those 2 points. Now let's square both sides and expand it. Now let's gather c squared sine squared B and c squared cosine squared B. Now we know sine squared B plus cosine squared B is 1. So this becomes a squared plus c squared minus 2ac cosine of B. So it turns out the law of cosine says in any triangle ABC with sides ABC, a squared is equal to b squared plus c squared minus 2b times the cosine of A. And similarly for b squared and c squared. The squared side corresponds to the cosine of that angle. C is 90 in the third form of the law, then cosine of C is 0. And we get C squared is A squared plus B squared, but that's just Pythagoras' theorem, which we've been using for years. Now suppose we have a surveyor who wants to find the distance between two inaccessible points A and B on opposite sides of a lake. Now while standing at point C, we find that B is 259 meters, while A is 423 meters. And I know the angle C is 132 degrees 40 minutes. Find the distance C. Well, this is just we want to use the law of cosines because we know the lengths of two sides of the triangle and the measure of the included angle. So if we look at C squared is equal to A squared plus B squared minus 2AB cosine C and substitute in our values, we get C squared is about 394,510.6, or C is about 628. So the distance between the 2 points is about 628 meters. Suppose we have a triangle ABC, and A is 42.3 degrees, B is 12.9 meters, and C is 15.4 meters. I know that A squared is B squared plus C squared minus 2BC cosine A. Substituting in my numbers, I get A is about 10.47 meters. Now, B is less than C since it's opposite the shorter of the two sides, B and C, so B cannot be obtuse. So let's use the law of sine to find the measure of the other angle. Let's do sine of A over A is equal to sine of B over B. Substituting in our values and solving, I get B is about 56 degrees. Now let's find the measure of the third angle, C, by subtracting the two known angles from 180, and I get 81.7 degrees. Now, had we used the law of sines to find C rather than B, we wouldn't have known whether C was equal to 81.7 or its supplement. So some of this is just trial and error. Now let's solve the triangle ABC if we know all three sides. We can use the law of cosines to find the measure of the largest angle C. And if C is less than 0, then angle C is obtuse. So let's start. C squared is a squared plus b squared minus 2ab cosine c. Solving for cosine, we get cosine of c is negative 34.341. So I know c is about 109.9 degrees. Using the law of sines, we can find angle B. Solving, I see that B is about 45.1 degrees. Now to find the measure of angle A, we know that 180 minus the two calculated angles gives me 25.0 degrees. Now suppose I want to find angle B to the nearest degree for the truss shown in the figure. So we're looking at this angle right here. So we want to look at B squared is a squared plus c squared minus 2ac cosine b. Putting in our numbers, we get b to be about 33 degrees. Now there are four possible cases when we're solving an oblique triangle. Now in the first case, we have side angle angle or angle side angle. We know one side and two angles. Now for these, I recommend you first find the third angle, knowing that the sum of the three angles is 180, and then use the law of sines to find the other sides. Now, if we have two sides and one angle that's not included, this is side-side angle. Now remember, this is a case that can't prove congruence in geometry. This is called an ambiguous case, and there may be no triangle, one triangle, or two triangles. So for the first step, find an angle using the law of sines, and find the remaining angle using the angle sum. Find the remaining side using the law of sines. And if you're going to have two triangles, repeat steps 2 and 3. Case 3 is side angle side. For the first step, find the third side with the law of cosines. So now you have all three sides. Now find the smaller of the two remaining angles using the law of sines. And then find the remaining angle using the angle sum formula. How can you know what is a smaller angle? Well, it's going to correspond to the smaller side. Now, if you know all three sides, you can use side, side, side. So find the largest angle using the law of cosines. Find either of the remaining angles using the law of sines, and then use the angle sum formula to find the last angle. Now let's talk about Heron's formula. When you have three sides, you can use Heron's formula to find the area of your triangle. The first thing you need to do is find the semi-perimeter, which is 1/2 a plus b plus c. Then the area of the triangle is the square root of s times s minus a times s minus b times s minus c. So now let's say the distance as crow flies from Los Angeles to New York City is 2,451 miles. From New York to Montreal, it's 331 miles. And from Montreal to Los Angeles, it's 2,427 miles. What's the area of this triangular region that has those three cities as vertices? The first thing you need to do is find S, which is 1/2 a plus b plus c, or 2,604.5. And then use Heron's formula, substitute in your values, and you get it's about 401,700 miles squared. Now let's derive Heron's formula. Let's let triangle ABC have lengths A, B, and C. If I apply the law of cosines and solve for cosine of A, I get cosine of A is b squared plus c squared minus a squared over 2bc. Now the perimeter of the triangle is A plus B plus C. So half of the perimeter, that is the semi-perimeter, is given in the following. So the semi-perimeter is 1/2 A plus B plus C. square fractions, I get equation 3. Now, I want to get b plus c minus a. So I want b plus c, and I want a minus a here. So I'm going to subtract 2a from both sides. So I get the equation b plus c minus a is equal to 2s minus 2a. And I want to factor 2 out of the right side. Now I'm going to subtract 2b and 2c similarly to get equations 5 and 6. So equation 5 is a minus b plus c is equal to 2s minus b. And equation 6 is a plus b minus c is equal to 2s minus c. Now, let's get the expression 1 minus cosine of a. 1 minus cosine of a is 1 minus b squared plus c squared minus a squared over 2bc. Let's get a common denominator and bring the a squared to the front and then subtract everything else. So we see that this is a squared minus b minus c quantity squared over 2bc. There is a method for this. So this is a difference of squares. So I can rewrite this as a minus b minus c times a plus b minus c all over 2bc. I'm going to take the negative signs and distribute it and get rid of my parentheses. Now, a minus b plus c and a plus b minus c can be rewritten as 2s minus b times 2s minus c. Now, one of these twos will go away. It doesn't matter which one. And so we're left with 1 minus cosine of a is 2 times s minus b times s minus c all over bc. We can show that 1 plus cosine of a is 2 s minus a divided by bc. Call the double angle formula for cosine of 2 theta. It's 2 cosine squared theta minus 1. So cosine of a can be rewritten as 2 cosine squared a over 2 minus 1. So 1 plus cosine of a is 2 cosine squared a over 2. Now let's make the substitution. 1 plus cosine of a is 2s times s minus a over bc. Simplify, getting rid of some 2's. That's all we did there. Solving for cosine of a over 2, that is equal to square root of s times s minus a divided by bc. That's equation 9. Now, we also know that cosine of 2 theta is 1 minus 2 sine squared theta. And so cosine of a is 1 minus 2 sine squared a over 2. So 1 minus cosine of a, rearranging this, is 2 sine squared a over 2. But we know 1 minus cosine of a is 2s minus b, s minus c over bc. Dividing through by 2, we get s minus b times s minus c over bc is sine squared a over 2. And we've come down to equation 10, which is sine of a over 2, is equal to the square root of s minus b times s minus c over bc. Now, the area of a triangle can be expressed as 1/2 bc sine a. So I'm going to multiply through by 2 to get rid of my fractions. And so 2a over bc is equal to sine of a, and that's going to be our equation 11. Now, remember the double angle identity for sine of 2 theta. Sine of 2 theta is 2 sine theta cos theta. So sine of a is 2 sine of a over 2 cosine a over 2. And 2a over bc, okay, that's sine a, is equal to 2 sine of a over 2 cosine a over 2. Substituting in what I had for sine of a over 2 and cosine a over 2. Combining everything underneath one radical. You see, I'm going to be able to do a little simplifying here. All right. We're just going to take the positive because we're dealing with positive distances at this point. So the square root of b squared, c squared is just bc. So now we see the 2's and the bc's cancel, and we're left with the area is equal to s times s minus a times s minus b times s minus c. The good news is I want you to know Heron's formula, but not necessarily have to derive it.